Welcome to MAPS Week 2, where we look at SLT4, understand what makes ratios proportional, SLT5, identify proportional and non-proportional relationships in tables and graphs, and SLT6, reason about the unit rate as a constant of proportionality. When comparing ratios, it's very important that each ratio uses the same units. Consider the image below comparing juices. Which one is a better deal? You may think that the juice boxes are a better deal because they're cheaper, and the ratio of cost per box could be seen as less than the cost of one jug. But a gallon is 128 ounces. So the comparison is really $7 to 128 ounces and $2.38 to 33.84 ounces. $2.38 is a little bit under 2.5 times to $7. And if you multiply 33.84 times 2.5, you would not get 128. So in this case, the jug is actually a better deal than juice boxes if you're looking at the amount of dollars per ounce. Proportions need to be consistent throughout a table. Consider the table below looking at miles driven per hours. Did the driver drive at a consistent rate? Is there a proportion between the values? You may think yes, because if you look at 60 miles per 1 hour, that equals 180 miles per 3 hours. It also equals 240 miles per 4 hours. But take a look at one other value. 140 miles over 2 hours does not equal 60 miles in 1 hour. So that means that the values are not proportional throughout. It also means that the driver sped up a little bit to go 140 per 2 and then slow back down. One of the possible ways to determine if two values are proportional is if there's a constant relationship between the two items. Words such as constant or consistent are words to look out for in word problems that may signal a ratio. For example, Jose ran 5 miles in 38 minutes. If he runs at the same constant rate, how long would it take him to run 12 miles? We can set it, looking at the word constant gives us a clue that this is a proportion. And we can set it up 5 miles over 38 minutes equals 12 miles to X minutes. We can cross multiply. We can use some of the other ways that we solved, and we can get that X equals 91.2 minutes. Thank you for taking the time to look at this video, and hopefully it helped you better understand what was covered during MAPS Week 2.